In this video, we will discuss the complete installation of the Atomic Simulation Environment, ASE, on a Linux system. ASE is a set of Python tools developed at the Center for Atomic Scale Molecular Design, CAMD, at the Technical University of Denmark, DTU. The goal of ASE is to unify the way one interacts with quantum physics and chemistry programs, with a focus on density functional theory, or DFT. ASE is released under the LGPL license. We will now give an overview of some of the advantages of using ASE. Typically, every DFT program has its own, often hard to remember, syntax of the input file that guides the calculation. Fortunately, ASE provides a set of objects and methods that are easy to manipulate. One simply creates a Python script that defines an atoms object on which common quantum modeling actions can be performed, such as finding the electronic energy, determining the geometry of the minimum energy structure or transition state, and determining the vibrational frequencies, or performing molecular dynamics. In this way, tedious tasks like verifying the convergence of an observable with respect to numerical parameters can be performed in a loop inside a single script. Another advantage of Python is through the analysis and presentation of the results, whereby units can easily be converted, plots can be made for further analysis, and the results saved in a database. One may also perform a set of the same calculations using different programs in order to double-check the correctness of a particular method. The current list of supported programs, called calculators, is on the ASE main page. The latest news about ASE can also be found here. The ideas behind ASE are described in the paper from 2002. You can find the reference on the Frequently Asked page. Please cite it if you find ASE useful. ASE was recently used by over 100 participants in a summer school materials modeling project, and the results were published in 2009. So, let's install ASE. The process is described at the download page. The installation is simple on a Unix or Linux system, and can also be performed on a Mac. All you need for a basic functionality is Python, including the Python development package that allows one to build Python extensions in NumPy. The programs matplotlib and pygtk are also very useful for presenting results. You can perform the installation of ASE as root, but as a first try, it's better to install on a standard account just in case something goes wrong. The recommended installation path of ASE is the home directory. Let's open a terminal. The account I use has a bash shell. Here I will simply skip setting the source from Subversion and download the latest stable release as tarball. You can use, for example, wget, then unpack the tar file. In view of having several ASE versions in the future, one being, for example, a development version, which you are welcome to contribute to, create a link to point to the default version. To finish the installation, two environment variables need to be set. One, Python path, which must include the location of the Python part of ASE, and two, path, which contains some additional Python scripts and a functional, lightweight molecular visualization graphical user interface called AG. Set these variables in the bashrc file and sort this file. Now we are ready to test the installation. Let's create a temporary directory because a few files are created by the test suite. If you don't have access to the display, or if matplotlib or pygtk are not installed, run the test without the graphical user interface, or GUI. It takes about 1 minute on a Pentium 4 to run the standard tests. The last test requires user interaction. It's waiting for the user to close the window, and only then does the suite terminate. If the test suite fails, please send the test.asc.log file and the system details, such as the operating system, bitnis, Python version, to the ASE users mailing list. I hope your installation will be successful, and you will enjoy discovering the features of ASE.